In this tutorial video, we'll be discussing a new topic which is called the theory of partial differential equation (PDE). When we talk about a PDE is a partial differential equation. It is a type of differential equation in which the dependent variable is a function of two or more dependent variables. If you have a dependent variable depend on more than two or more independent variables, we call the differential equation as a partial differential equation, which is known as what? PDE. So let us consider what is on the board. I wrote that a partial differential equation PDE is an equation which involves one dependent variable z or u and more than one independent variable x, y, t, and one or more partial derivative of the dependent variable with respect to the independent variable. We have a dependent variable depend on the function of more than one or more independent variable. We call the equation as a partial differential equation, and this is the symbol for the sign. That is, the dependent variable depend on what? More than one or two independent variable. So that's why we said with respect to the independent variable. So it means we are differentiating with respect to what we are asked to do, not only one variable that we are going to have. We are going to have more than one, that is two or more independent variable. So let us consider example. If you have s partial z over partial x plus y partial z over partial y is equal to z. These are examples of a PDE, which is partial differential equation. The reason why is that you can say for this example that this variable is not only one independent, is not only one dependent variable there. You can see x here, you can see y here. Whenever we have a dependent variable depend on more than two or more independent variable, which is not only one, we call it a what? Partial differential equation. You can see for the second example, we have the square z all over the x square plus the square z over the y square is equal to 0. This is also a partial differential equation. Partial square z all over partial x square, that is, we are having a z, a function. The function is a what? The function, the dependent variable is z, depend on what? X and y. Why this one is a what? The function, we are having function if a variable and x as a variable multiplying what? A partial differential equation, and we call this one a Laplace equation. So Laplace equation is an example of what? Partial differential equation. So let us move to order of a PDE. Order of PDE, order of highest partial derivative occurring in PDE. When we talk about order, the highest partial derivative occurring in a PDE. Let us consider this example to check our order of what? Our order of a PDE. It means you can see that we have partial z all over partial x. That is, the derivative of z depend on only x variable, while the derivative of z here depend on what? Y variable. Z here is a function of x and y. Z here is also a function of what? X and y here. Z is the dependent variable which depend on x, which depend on a function of x and y. So we can see that the highest power, the is first order. Why? The reason why this one is a first order because it's only the z all over the x you have. But if you have the power, if you have the derivative, the dependent variable, the partial derivative variable is more than one, that is, we are having something like this. There is square partial z or the square z all over the x square. You can see from here that what do we have here? We have a partial sign, that is del, raised to the power of 2. It means this one is order 2. You can see from here, what do we have here? The power here. What we have here? The power of del here is 1. 1 is what? We give you the z is what? 1. So that's why we said the order of the highest power. We call it. Suppose we have 3 here, we have 2 here. It means the highest power is 3. The order is 3. But in this example, you can see that the order of here is what? Order 1. First order PDE, that is first derivative of partial differential equation. And the second one I've explained. What do we have? We have order 2, that is second order PDE. The reason why is that we are differentiating x twice, we are differentiating y twice. So the highest power of x here is what? Is what? 2. So the highest partial derivative occurring in PDE is what? 2. So let us go to degree of PDE. Degree of highest order derivative which occur in the equation. You can see from here, we will consider the same example that we were given when we were defining partial differential equation. You can see that the order, when we talk about a degree a degree is the highest power of that highest order derivative and equation. You can see from here there is z all over the s. If I put this one in bracket, the power of here is 1. So it means the degree is what? Is 1. Partial differential equation. You can see from here, if I put this one also the bracket, if I put this one inside bracket, the power is what? 1. Suppose I have this one as 2 here, I have this one nothing. It means the degree here is 2. But since we don't have anything here, the power that is to the highest power here, it means the degree is what? Is 1. So if z is a function of f of s, y of two variables, then we shall use the following notation for the derivation. And we move on, we're going to consider how to form a PDE, formation of PDE, where we are going to use this our notation. And this notation means that whenever we see there is z all over the s, that is, we are differentiating z with respect to x, it is what? It implies that we are going to use p. Whenever we see there is z all over the y, it means it implies that we are going to use what? Q in place of what? There is z all over the y. But whenever we see how we differentiate x twice, there's the square z all over what? The s square. Partial square z all over what? Partial s square. It means we are going to imply the square z over the s square as what? How? Whenever we see x, you can see from that, if I differentiate the square z all over the s, the y, I'm going to have what? The square z all over the y, the s. A good example is that if I have z of sy, I have 5s square plus y here. You can see that this z is a function of xy. So it means if I said the z, if I differentiate z of x, zx, this means that what? I'm differentiating anything here is what? This thing means I'm differentiating with respect to x only. So I'm going to have 10x. If I differentiate zy means partial y, partial z all over what? Partial y. So I'm going to have what? If I differentiate y, I'm going to have 1. 5s squared will be 0 because it is a partial differential equation. We are only differentiating only with respect to that value that we ask. But if I differentiate zxy means I'm differentiating the s, the y. So I'm going to consider my zx. Where is this my zx? Differentiate y. If I differentiate y here, there's no y to be found. And remember that in partial differential equation, if you are differentiating with respect to that value and it is not there, it is going to be a constant, which is 0. So zyx. So we are differentiating with respect to x. I'm going to go to my zy. I'm going to differentiate x. 1 is what? 0. 1. There's no x here. I'm going to have 0. You can see that if our answer for zxy must be the same thing with what? Zyx. So in that case, whenever we have the z, the s, the y, the s, the y is also equal to what? The y, the s. So that's why we have this one. So it means whenever we have the square z all over the s, there's one. You can see that we differentiate this one in two places. We differentiate x first. After we differentiate with respect to s, we now differentiate with that x with respect to y. We differentiate y first, then we now differentiate again with respect to s. That's what it's a order 2. So that's why we have order 2 here. So it means this one must be equal to this. It's either we write it as this or we imply it as this. So that is for s. But for t, it means the square z all over what? The y square. So it means if whenever we have the square z over the y square, we are going to imply that the square z over the y square is equal to t. We use this notation to form a PDE. When we get to the formation of PDE, where we are going to see this the z all over the s, we are not going to be using the z over the s. We'll be using it in case of implies of what? P. We are going to use P, Q, R, S, T. This is just the basic on partial differential equation. So in the next video, we are going to talk on how to form a PDE. Don't forget to subscribe and share to your colleagues and others. Thanks for watching.